All right, here we go. 1.2, visualizing graphing data. Our goals for this section are to review concepts that you would have learned in elementary, middle school, and Algebra 1. Okay, so that's what this is. So it's like a hodgepodge of all these things. And yeah, so starting in elementary is remembering your data analysis, data statistics analysis words. So like finding the maximum, the minimum, the mean, the median, the mode, the range, right? When you're finding your maximum, it's your largest number in the data set. Your minimum is your smallest number in your set of data. Your mean is the average, remember? And when we're finding the mean, that means we're doing what? Exactly. It's the sum divided by the number of numbers, right? Right? Yes. Okay. That's a number symbol. Go with it. Your median requires you have to put everything in order from least to greatest. And you're looking for what is in the middle. If it's an even set of data, then you're going to find the average of the two in the middle. Okay. Your mode is your most used. Mode is most often in a set of numbers. If there is no number that is being repeated, then your mode doesn't exist, right? And then your range is the difference between your max and your min. So your range is simply your max minus your min. Okay. So really quick, we're going to go through that with this data set. So the table shows the degrees in Fahrenheit in Minneapolis, Minnesota for 6 consecutive nights. I wouldn't want to live here if this is my degrees. Okay. This is all in Fahrenheit. So negative 12 degrees Fahrenheit. No. Y'all can have that. Not I, said the cat. Okay. What was their maximum temperature? 21 degrees. What was their minimum temperature? Negative 12 degrees. Who lives in that? Okay. How do you still go to work and school? I wouldn't go anywhere. And your range is simply your max minus your min. So our max is 21. Our min is negative 12. A negative times a negative makes a positive. So this becomes 33. So our range is 33. Your mean is done in 2 parts. Step 1 is to find your sum. So I'm going to add up all these numbers. We're going to add them up out loud. How about that? Negative 12 plus negative 4. Negative 16. Negative 16 plus negative 8. Negative 24. Negative 24 plus 21. Negative 3. Negative 3 plus 18. 15 plus 9. 24. So our sum is 24. Step 2 is where you actually are going to find the mean, the average, right? And the average means that you're going to take your sum and divide it by the number of digits. Well, not digits, numbers you added up. And so how many numbers do we add up? 6. So our average is 4. So their average temperature is 4 degrees over the course of the 6 days. Again, I wouldn't have left my house. Okay. I don't want to leave my house if it goes below 30. So I know, but I'd be so layered. The median. The median means that you have to put them in numerical order from least to greatest. So if I'm listing them in numerical order, my first digit would be negative 12. Next would be negative 8. Next would be 4. Next would be next 18. And last but not least is 21. So the 2 that would be in the middle would be negative 4 and 9. Because we have an even number, that means you have to find the average between those 2. So the average would equal negative 4 plus 9 divided by 2, which gives me 5 divided by 2. So the median temperature is 2.5 degrees Fahrenheit. Anything that I said you don't remember? Okay, and there's no mode. Why is there no mode? No numbers repeat. All right, next thing we're going to talk about is, so this is single variable data, which means that you only have one thing to analyze, right? Then we move into 2 variable data. 2 variable data means that you now are analyzing the relationship between 2 things, okay? A relationship can be represented as an ordered pair. So you can represent it as an ordered pair. A relationship can be represented as a graph, a mapping, a table, or some form of an equation. So those are our 5 representations. Within your relation, now that you have 2 sets of 2 variables, those 2 variables are typically called the domain and the range of your data. Does that ring a bell? Yeah. Okay, so domain and range. And now we're going to talk about other ways that domain and range can be represented. So again, our goal is to make sure that we can read 2 variable data in any of these formats. Do we feel comfortable in all 5 formats? That's for a function. We're just talking about a relation. Yeah. Right now it's just comparing 2 sets of data. We're just looking. Yeah. So the mapping one works. So all of these are the same data set being represented, right? So these are our ordered pairs, and these ordered pairs can be plotted on a graph, X and Y. When you're mapping them, that means that you're going to look at all of your X's and they don't repeat. Okay. So I have 0, 3, and 4. Then you're going to look at all of your Y's. I have -2, -2, -2, +2, -1, 1, and 0, right? And when you're mapping, you start at the X and you draw the lines from the X's to the Y's. So your X's to your Y's. And that's it. All right. The table way of representing it. And then last is using equations and words. So y equals 4 minus x, and we're only analyzing it where x equals 0, 3, and 4. Got it? All right. So Dixie and Roy. Dixie and Roy are our ways to remember what domain and range are represented by. Your domain is the relationship of your input values. What are you starting out with? What are you putting in to see what happens, right? Is it time? It's typically going to be your time or your things you can't control, right? Like your height, not your height, time. Can't think of any other example right now. They'll come up. But I think of them as 2 old hound dogs, Dixie and Roy. So your domain, input, X value, and independent quantity all mean you're defining that X value, your X's. Your range are going to be your output values. And that's going to be Roy. Range, output, your Y values, your dependent quantity. So a problem may ask you, what's the range? What's the output? What are your Y values? What's your dependent quantity? And it all just simply means you're listing out your domain, your range, right? They're all synonyms for each other. Okay. Do you remember this from pre-algebra and algebra? Okay. If not, remember, y'all are my stoplight. So, like Miss Jones, I don't understand. All right. Finding the domain and range of a relation. So here you have a physics class. They measure the time it takes for an object to at a certain feet to fall, and then they record the time. So in this case, our independent is what we control, and what do we control? How high we hold it up, right? So that's why it's our X. So this is our independent variable. What we can't control in this case is time. So that's our dependent variable. Does that make sense? So we're measuring. So if I drop it from 20 feet, it goes down to, how long did it take to hit the ground? 1.2 seconds. I dropped it from 20 feet again, and this time it took 1.1 seconds. I dropped it from 40 feet, and it went 1.5 seconds. I dropped it from 40 feet again, and it took about 1.6 seconds. Okay? So I'm collecting the data based on a given criteria. All right? Now, establishing what is, if I want to express this as a relation, I already have it written as a table, so I'm going to write it as an ordered pair. Or I can write it as a mapping, but I'm going to express it as a relation. So expressing as another version, we're going to just go ahead and write it as an ordered pair. ordered pair, as long as my X and Y's that are vertically connected stay together, that's my set. Does that make sense? Now from this ordered pair, we're going to state the domain and range. When you're stating the domain and range, you do not repeat values, and you're going to list them from least to greatest, okay? So we're not going to repeat values, and we're going to list them from least to greatest. So for your domain, you actually are only going to have how many in your written domain? How many values? 2, because they are repeating values, right? Does that make sense? Okay, your range, I don't have any repeating values, so I'm going to list them all. Okay, this is called a discrete data set. And discrete data set means that I can list exactly what the domain and range is without using inequalities. We will talk about non-discrete later, but this is a discrete data set because I can specifically list these things. All right, are we comfortable with just identifying domain and range? Okay, again, when we're listing, do we repeat? No, we do not repeat. And we list them in order from least to greatest. Uh-oh, I went too fast. Go back, go back. All right, now we're going to talk about the XY plane. We're going to use its formal name. Its formal name is Cartesian Rectangular Coordinate Plane. Okay, that's its formal name. Yes, it has two middle names. This is its nickname, Rectangular Coordinate Plane. But Cartesian is its first name, okay? This is Cartesian. It's the dude who discovered it. Cartesian is its first name. So in our XY plane, we're going to identify everything about it. We have our x-axis. Your x-axis on the right side is your positive x's, and on the left side are your negative x's. We have our y-axis, that is our vertical axis. Our vertical up top is our positive y's. Down below are our negative y's, okay? We have a center where our x and y intersect at a 90-degree angle, and that's called our origin. Okay, once we have our origin, we have our quadrants, and our quadrants are divided into four parts, and they are numbered using Roman numerals in typical form. So quadrant number 1 and quadrant number 1, your x and your y are both going to be positive. Okay, and quadrant number 2, your x is negative and your y is positive. And quadrant number 3, both your x and your y are negative. And in quadrant number 4, your x is positive and your y is negative. When you plot points into the Cartesian plane, that creates what we call a scatter plot. From that scatter plot, you will eventually learn about functions and see if there's relationships, what kind of relationship exists from there. But the main thing is just plotting the points. Okay? Points can lie on your axis or lie in your quadrants. So what we're going to do is I'm going to show you a series of points, and you're going to tell me where would they be located on the Cartesian coordinate plane. All right? Here we go. What quadrant would 5, 10 be in? And quadrant 1. What quadrant would 5, -5 be in? 4. What quadrant would -10, 10 be in? What quadrant would 0, 5, 0, 15 be in? There we go. It's not a quadrant. It's on the y-axis, okay? I know it's on the y-axis because the x equals 0. What quadrant would -15, -10 be in? It's in the third quadrant, okay? Could I find the domain from this set? Yes, the domain in this case is going to consist of what? And when I list them, they need to be in what? Least to greatest, okay? My range would consist of and I would list them in order from least to greatest. Okay, what is the maximum number? And my min. Once you identify your domain and range, your min and max should be the tail end. Does that make sense? So in my domain, my max is 5, my min is negative 15. In my range, my max is 15 and my min is negative 10. Make sense? Okay, and then you should be able to plot the points. I'm not going to make you plot the points. If you want to practice plotting points, I will let you do that at a later time. Oh, go back. Go back. Back. Yes, that's a ode to COVID times. And plot the points. Easy enough? Remember this? All right, line graph. So what is a line graph? Well, a line graph is sometimes helpful to connect the consecutive points of the scatter plot with straight line segments. That's literally all you're doing so that you can analyze what are they doing, like what's the change that's taking place. So typically when we plot our points, we then are going to connect them and then we can describe from here to here, is it increasing or decreasing? From here to here, is it increasing rapidly, slowly, like what's taking place? You're only connecting with lines from point to point, okay? You're not trying to find a shape to best fit. You're just connecting the points, okay? So for example, we're going to look at a graph. I'm not going to make you plot the points unless you want to. I can give you graph paper or you can grab graph paper, but we're going to kind of look at it and then talk about it. Cool? All right, so here we have our data. This is the average monthly precipitation in Portland. And I thought people were joking about the rain in Portland, but it does rain. Because it rained like pretty much the entire time I was there in December 1. And so this is the amount of rain again. I was in this rain, that amount of rain. So we're going to plot these points. When we look at this data, what we are controlling is the months, right? We're looking at January, February, March, April, May, June. So that's why this is our X, our independent. And then what we can't control is what happens, right? That's our dependent. That's our Y. What is happening with Mother Nature? So this is a split table and the data goes together. So it's just a split table. All right. So from there, I would plot the points. And now I'm going to look at the points. Okay, cool. Yeah, there's my scatter plot. Now, because you are probably like, an advanced mathematician, you're probably like, oh, I see a quadratic. If you do, good job. Okay. That's not until chapter 2. So don't worry about it. We'll get there. What I do need you to know is that now we're going to create a line graph. Creating a line graph means that I'm literally just going to connect from point to point, left to right. Okay. And when I do that, this is what a line graph looks like. All right. The line graph allows you now to say, okay, well, from January to February, there was a large decrease in the amount of rain we were getting, right? All right. There was a little steady increase from February to March, and then, a little drop again. We had a little dry season, I guess. And then, boom, rain, right? So it allows you to look at it from intervals on smaller intervals and analyze what's taking place. That's a line graph. Questions about a line graph? Okay. Ignore stop recording. I thought I've deleted them all, but some are still in there. From my COVID times, I used to make smaller videos in chunks, like 3-minute videos, and hopefully people wouldn't get annoyed watching them at home. All right, distance formula. The distance formula is the cousin of the Pythagorean theorem. Do you guys remember Pythagorean theorem? A squared plus B squared equals C squared. So A squared plus B squared equals C squared was the way that you could find the measurements of a right triangle, correct? So if I plot a right triangle into a Cartesian plane, what I'm now measuring, my A squared, is now measuring the distance between my Y's. Does that make sense? How much have my Y's changed? My B squared is now measuring the distance between my X's. How much have my X's changed? And my C is the distance between the 2 points that help me create my triangle. Does that make sense? And that is where we birth the distance formula. Okay? So the distance formula is the cousin of who? Pythagorean. And here she is. Okay? For your distance formula, you will have 2 distinct points, x1, y1, x2, y2, and you will simply just plug them in. You're either going to be given the 2 points or you'll be given 1 point in the distance. The order that you plug in, as far as whether the 2 or the 1 comes first, doesn't really matter. What matters is that if your x2 is first, then your y2 has to be first. Does that make sense? If your x1 had been first, then your y1 has to be first. As long as your corresponding x's and y's are in the same place in the problem, then you're good to go. Did we get it down? Are ready to use it? Sure. All right, so here we go. So we have our example. 3 and -4, -2 and 7. So if you are going to practice, I'm going to pause and then we'll see how we did. Cool? And go. Okay, so hopefully we actually tried. Again, sometimes it helps for people to label what's their x1 and their y1. So I'm going to practice labeling. So if I let x1 equal 3, y1 equal -4, x2 is -2, and y2 equals 7. This helps people just pay attention to where they're plugging things in. So I'm going to find distance equals the square root of, my x2 is -2, my x1 is 3, plus my y2 is 7, my y1 is -4. As you're doing your homework, I strongly encourage you to have a notebook and actually be working the problems. Because one, it's good practice. And sometimes if you write it out before you do any kind of calculation, you'll catch your errors. -2 minus 3 is -5. -5 squared is going to give me 25. Agree? Plus, a negative times a negative is a positive. 7 plus 4 is 11, and 11 squared is 121. This is going to lead me to the square root of 146. And the square root of 146 is approximately what? Rounded to the nearest 100. What'd y'all get? 12 and 800ths. Can we do distance? Easy peasy. All right. The next formula that we're going to go over or review is midpoint. Both of these should be familiar from geometry. Midpoint. Do we remember midpoint? Now, I want to make y'all very, 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 very aware that in between is a comma. It never fails that I have a student that'll make this comma into a plus sign. Okay? You are finding the midpoint, which means that you need a point. I need an XM and a YM. Okay? These are two separate things you're doing. You are finding the average of your X's and you're finding the average of your Y's. Does that make sense? Okay. Do not try to put them together. They are totally separate. All right. So again, you're just finding the average. So you're adding, dividing by 2, because you only have 2 X's and 2 Y's. When you're looking for the midpoint, halfway point. Yeah. All right. Yeah. All right, here's your example. Go. All right. So was that terrible? Easy peasy, right? So you're identifying your x's, 6 and -4. So I have 6 plus -4. Then you're going to identify your y's, comma, -7 and +6. Okay. This is a comma, not a plus sign. Why am I reiterating that? Because it never fails on a test. Someone adds these two together and give me one number instead of an ordered pair. All right, 6 plus -4. I have $6. I spend $4. I'm left with $2. 2 divided by 2 is 1. I have -7 in my bank account. I go deposit $6. I now have -1 in my bank account. And fractions are our friends, so -1/2 is acceptable to write. Yes, midpoint, can we do it? Yes, perfect. All right, continuing with our geometry review, we're going to dive into the equation of a circle. So in geometry, you guys should have talked about all things circle, okay? And the number one thing is the equation of a circle that we need from that information. The equation of the circle tells you the center, which is going to be your h and your k, and it tells you your radius. Your radius is going to be the square root of your constant. Constant just means it is not a variable, right? All right, notice that your h and k are being subtracted. They look like they are negative, but they're actually positive values. They're actually positive. If your circle was written as x, I think I need to change the tip on my pen. My pen here, because she's starting to do weird things. I'll do it later. I will change it later. Just let me make it through the notes. Okay. If it said x plus h squared plus y plus k squared equals r squared, that means that you have a negative h and a negative k. Okay. So x minus h, y minus k mean that h and k are positive. If it says plus h or plus k, that means that h and k are negative. It's the opposite of what you think, okay? All right, so you have the center and your radius is the distance to any point on the outside of the circle, some x and y. Notice here in the middle, I wrote note, if the circle is at the center, will you have a visible h and k? No. Is it necessary to write x minus 0? No, that's just crazy. All right, so just to make sure that we understand, we're going to look at a very easy one first, okay? Here's my equation of my circle. X squared plus y squared equals 9. I want you to tell me what is the center, what is the radius? What is my center? What's my center? It's what? Yeah. 0. It's at the origin. Why is it at the origin? Because there's nothing being added or subtracted to the x and the y. Does that make sense? There is nothing being added or subtracted. Okay? Now your radius. The radius is the square root of your constant. Your constant is the number with all alone. So our radius is the square root of 9. And what's the square root of 9? 3. Easy peasy. Okay, I'm going to erase this so that the graph can pop up. So we had our center is at 0. And our radius is 3. Your radius being 3 means that on the x and y axis, you're going to go out 3 units. And I can do that at the x and y axis because my origin is my center of my circle. And then, boop, circle. Yay. All right, let's try this one. So tell me, what is my center? Good job. 1, negative 2. And why is it negative? It's the opposite of what you see, right? Your radius it's 2. Why is it 2? It's the square root of your constant, and our constant is 4. So therefore, my radius is 2. So this time I have a circle that is at 1, negative 2. And going left and right, up and down, I'm going to go 2 units out. And this is what it would look like. Yay? All right, now we're going to go backwards. We're going to find the equation of the circle. So in order to find the equation of the circle, you have to know your center and you have to know your radius. So if one of those pieces of information is missing, we have to calculate it. Does that make sense? Okay. So here, it gave us our radius. It gave us our center. Do I have everything I need to write the function, the equation? I'm sorry. Yes. So starting off with my x, I have x. It's a negative 3, so it's going to look like what? A positive 3 plus negative 5 equals 16. It's your radius squared. The constant is the radius squared. If your radius is the square root of your constant, then vice versa, inversely, it's not vice versa, inversely, it's going to be, you got to square it. Easy enough? Okay, so that would look like this. And again, pay attention, signs are going to be opposite because the original formula already has a negative in it. All right, now what if I'm given the center, so I know my h and my k, and I'm given a point on the circle? What information would these two things help me find? What's missing in order for me to write my equation? The radius. I can't solve it. I have to find the radius. I wonder, is there something I can use to find, I don't know, how far apart 2 points are? The distance formula. So the first thing I have to do here is use the distance formula. The distance formula is going to help me find my radius. Does that make sense? I know I'm using the distance formula because I have 2 points and I'm trying to find out how far apart are they. In order to do this, I'm going to have to do the square root of x2 minus x1 squared plus y2 minus y1 squared. To show you guys that it doesn't matter which is your x2 and your y2, maybe your x2 or your x1, I'm just going to go from left to right. Is that okay? So I'm going to let 6 be my x2. Therefore, 1 is my x1. Since 6 was my x2, that means that negative 3 has to be my y2. And 2 is my y1. Six minus 1 is 5. 5 squared is 25. Negative 3 minus 2 is negative 5 squared is 25. 25 plus 25 is 50. We're going to leave that as a radical, okay? Because this isn't where you're stopping at. If this is where we're stopping, cool. But is this where we're stopping? No, we still have to write our equation of our circle. So step 1 was to find our radius using the distance formula. Step 2, now we can write the equation of our radius. The reason being is that we now know, we already knew our center. So we know that h equals 6, k equals negative 3, and now we know our r, and r equals the square root of 50. It would be 2. A negative times a negative makes a positive. So we have x minus 6 squared plus y plus 3 squared equals the square root of 50 squared. What happens when you square a square root? They're inverses, so they do what to each other? Cancels out, and it's just going to become 50. And that is an example reason why we do not use decimals until the very, very end. Because if I had changed it to a decimal, will it came out smoothly to 50? No. So the equation of our circle is x minus 6 squared plus y plus 3 squared equals 50. So you see how knowing one piece of the information helped us solve another? Because math builds on each other. Okay, now the next piece of what we're going to learn is called completing the square. Completing the square is necessary for when you are given a circle equation not in standard form. Okay, so the circle equation that we were given was our standard form of a circle equation, but it's not going to always be written in that form. So this is the form that you also can get a circle equation in, but that is not the correct form. And well, it's a form, but it's not. So we're going to talk about we're going to learn how to change this into the correct form. Okay. So we're going to go back. And in order to do that, we have to do what's called completing the square. Okay. When we're completing the square, it is typically used when you're solving quadratic equations. We'll talk about that later. And the goal is to turn one side into a perfect square trinomial. So going back to Algebra 1, a perfect square trinomial means that if you have x minus a times x minus a, it's going to equal x squared minus 2ax plus a squared, right? So it comes out to be a perfect, and this condenses all down to x minus a squared. Isn't that the form that our circle of equation needs to be in? Okay, so our goal is to be able to make this. All right, so how do we do this? Well, there are 6 steps we follow. The first thing you want to do is you want to transform the equation so the constant term c is alone on the right side. We want to make sure that we move c. We got to move our constant. A constant is a term that does not have a variable. And we want to move it to the right side. Once we've moved it to the right side, we're going to look and see if a has a coefficient. If a doesn't have if a is anything other than 1, then we're going to divide all sides by a. If it's already 1, then we're good. Next, you're going to find what I call our magic number. It's not the, lo siento. It's not the most mathematical term, but I call this our magic number. Your magic number comes from taking your b dividing by 2a squared. What does that sound like? If I say b divided by 2a, what does that make? The quadratic formula, right? Because that's all, it all comes together because it's all about quadratics, right? So we're going to find our magic number, which is just the outside of that quadratic formula, the b divided by 2a, okay? And we're going to square it. And once you have that, you're going to add it to both sides. We add to both sides because this is an equation, and equations have to stay balanced. Next, we're going to factor the left side as a square binomial. So our goal is to write the left side as x minus a number squared. That is what a squared binomial is, okay? Then we're going to take the square root of both sides, and then we're going to add or subtract. When you take the square root of any number, it's going to create a plus or minus. And the reason why it creates a plus or minus is because a negative times a negative makes a positive. So technically, it could also be a negative. And then the last step is to solve for x. In order to solve for x, that means we're either going to be adding or subtracting our last term away. Okay. And the goal here is to just fully simplify. Are we ready to see a completed problem? And then we're going to do a problem together. Got it? So here's our completed problem. So step one, it says to make sure that C is moved. Is our C moved? Yes. So this is step one, is to make sure your constant is by itself. So this guy has now been moved to the right side. Step two is to divide by A, but our A is 1, so there's nothing to divide by. So we're going to go straight to the other step 3, which is finding your magic number. Okay? Your magic number is your B, and in this case, our B is -4 divided by 2 times A, and because our A is 1, it's just going to be 2. What is -4 divided by 2? -2. What is -2 squared? 4. Now you're going to take your magic number and you're going to add it to the left and you're going to add it to the right. That's called completing the square. And now we're going to factor and simplify. So what multiplies to give me 4, but adds to give me -4, that would be a -2 and a -2, correct? So instead of writing it as x minus 2, we just write it as x minus 2 squared. 6 plus 4 is 10. Our next step says to take the square root of both sides. The reason why we take the square root of both sides is the opposite of squaring is to take the square root. 10 does not have a perfect square. 10 is not a perfect square, so therefore it stays underneath the radical. And remember, it's going to produce a positive and a negative. The last step is to get x by itself. In this case, to get x by itself, we're going to have to add 2 to both sides. You either can work it as 2 separate problems because of the plus and minus, or you can work it as 1 problem. And now x is by itself. This is fully simplified. So the answer would be x equals 2 plus or minus the square root of 10. On your homework, you will have the plus or minus button. You're going to use the plus or minus button when you can't simplify anymore. Does that make sense? All right, we're going to do a very easy one going through the process. Are you ready? Please write down x squared plus 6x minus 7. Step 1 tells us to do what? Move the constant. So we got to move our -7. How am I going to move the -7? By plussing, right? I'm going to add it to the other side. So now we're down to x squared plus 6x equals 7. Optional step 2 is if your leading coefficient is not a 1, then you're going to divide everything by that. Ours is luckily a 1. So do I need to divide? No. So I keep going. Next, we're going to find our magic number. Your magic number is your b divided by 2a. So in this case, squared, we have 6 divided by 2a squared. And that makes what? 9. Step 3 is to add your magic number to both sides of your equation. So we have x squared plus 6x plus 9 equals 7 plus 9. Step 4 is to factor and simplify. So when I'm factoring, I'm asking myself what multiplies to give me 9, but will add to give me 6. What kind of 3? Just positive, right? So it becomes x plus 3 squared, because I would need how many 3s? 2. equals, and 7 plus 9 is 15. 16. You didn't see that. What are you talking about? 16. Okay. Step 5 is to take the square root of both sides. Taking the square root because that's how we are going to start solving for x, right? They're inverse operations, so these are going to cancel out. And we're left with x plus 3 equals plus or minus, and what's the square root of 16? 4. And then the last step is to get x by itself. What's my last thing to get x by itself? Subtract the 3, and we get x equals -3 plus or minus 4. Because this doesn't have a radical, that means we actually can evaluate it. The plus or minus means that you have one that's being added, so you have -3 plus 4. The minus, -3 minus 4. So our two solutions would be 1 and -7. If you remember anything from factoring, that makes sense because this is a simple factor, right? Simply, you're asking yourself what multiplies to give you -7, but adds to give you +6. So my factors would be x plus 7 and x minus 1. And I would still get those answers, right? Do we see how these would still make the same, those answers? Going back to good old factoring. All right, was completing the square that terrible? No. All right. So now, how does it help us write our circle in the correct form? Well, writing your circle in the correct form is important because notice here, we are not in our circle form. And our circle form is your x minus h squared plus y minus k squared equals r squared, right? And are we in that form? No. So we're going to have to rewrite this into that form. So that means we're going to do a little completing the square in between. So we have to complete the square for each one of these. Essentially, we just have to find our magic number. So we're going to find the magic number to add to both sides. Does that make sense? So on this one, for our x's, our magic number would be 4 divided by 2 squared. For our y's, our magic number would be -6 divided by 2 squared. Does that make sense? Okay, so our magic number here is going to be x squared plus 4x plus 4. Our magic number here, we have, that's not a y. It's going to be y squared minus 6y plus 9. Because I added the 4 and the 9 to the left side, I also have to add 4 and 9 to the right side. If I don't, are these staying balanced? No. So now we're going to factor. What multiplies to give me 4 but adds to give me 4? That would be a 2 and a 2. What multiplies to give me 9 but adds to give me -6? That would be a -3. So -3 squared. And 5 plus 4 plus 9 is 18. And now, oops, why do I want to keep writing that as an x? And now, are we in our circle form? Can you tell me what my center is? What's my center? Perfect. And my radius would be square root of 18. Remember, the radius is the square root of your constant. All right.